Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic this morning will be a discussion on the so-called switching power supply. Most big screen TVs now, the power supply is actually switching power supply. It's a complicated thing. Why complicated? Because the voltages needed for big screen TVs, there are lots of DC voltages that is needed, like the voltage that will power up the main board, the audio board, and the other boards. Those are all direct current power supplies. Like the main board, maybe the one that will control the big screen TV, the voltage might be 5 volts. For the audio module, maybe it could be 12 volts and some other things. Okay. So what I will be discussing is not the exact power supply of a big screen TV. This is just to give you a hint on how the power supply of big screen TVs actually being what you call this produced. So right here, I bring out my old assembled switch mode power supply. It's not assembled because I bought the module, then I put a case, then I make sure that the voltages coming out from the switch mode power supply inside are actually these ones here. It's done. So actually for this example here, I got a 5-volt power supply. Between ground and this one, it will be 5 volts. Between ground and this, it will be 12 volts. Between ground and this one will be 12 volts. Between ground and this one will be 12 volts. And between ground and this will be 5 volts. So actually this example here, actually we got a switch mode power supply in which the output is actually 5. And just to give you a hint on how this power output of these voltages are actually being brought out, I will just give you the summary on the secondary portion. For a switch mode power supply, what is needed on the secondary are the so-called high-frequency transformers. Those small, what I call these transformers, they are minute because even though they are small, and since their frequency is high, okay, they could generate a voltage like this one here. This should be a minute high-frequency transformer. If the frequency of this is high, it could generate 5 volts. If the frequency of this one is very high, maybe in the hertz or megahertz range, okay, it could produce 12 volts. Like this one here, it could produce 12 volts. Next one, it could produce 12 volts. The next one will be 5 volts. So these are all located on the secondary side, on the switch mode power supply inside. So this is just a summary. I'm just giving a summary on how the different voltages are actually produced. For this to come out, there should be a so-called switching transistor on the primary side. The switching transistor is a complicated design. The design is that such that when the power supply is plugged into the AC source, this switching transistor will try to produce a high frequency which will be applied to these high frequency transformers here. So the lifeline of these secondary voltages is actually the switching transistor. For as long as the switching transistor is actually activated, it is producing the required high frequency, maybe in the megahertz range or kilohertz range. Okay? If this is alive, all the high frequency transformers that is being connected here or interconnected here, it's a complicated design, will be alive. So if this is alive, these 5 high frequency transformers will be alive, and if they are alive, okay, they could produce voltages. It is something like that. So that's how a switch mode power supply produce the different voltages on the secondary. The lifeline is that there should be a switching transistor. Okay? It's a high current capacity. It should be a high current capacity because this one here will try to feed this one here, feed this one, feed this one, feed this one with the frequency required for it to oscillate. Okay? Because for a transformer to operate, there should be a frequency on the primary and the frequency on the secondary. Frequency on the primary, secondary, something like that. And where will the frequency in the primary of the different high frequency transformers emanates? It is coming from the switching transistor. So like what I said, the lifeline of these high frequency transformers is actually the switching transistor. So if the switch mode power supply is dead, okay, if all the output voltages are dead, okay, the first culprit that you will be troubleshooting is actually the switching transistor. This might be dead. If this is dead, it could not produce the required frequency for the high frequency transformers to operate. Okay, I just give you a preview on how to troubleshoot a switch mode power supply. But the way and how to produce a different voltages on a switch mode power supply, it is something like this. Okay, let's try to, at least we now know how we produce the different voltages, right? So I am giving you an actual example now. This is a switch mode power supply. The switch mode power supply circuit is inside. I assembled this one when I got a electronic shop in Carson 10 years ago. So I know how to troubleshoot switch mode power supply. It is a complicated thing. It's a complicated thing, right? So just to give you an example, like this one here, I will be checking the voltages of this one. If these are really 5 volt, 12 volt, 12 volt, 12 volt, and 5 volt, I got 2 ground connections. If we see ground, this ground here is same as this one. Okay, so I got my multi-tester, and I will try to switch on now. I switch on, I plug in the switch mode power supply. This time I don't have the LED. I could place the LED later on. LED meaning I put an LED indicator here. If the LED is lighted, the voltage between ground and 5 is alive. Later on I will place those LEDs. But just to show you that this switch mode power supply is alive, I got my multi-tester set to measure DC voltage. This is the ground portion. It is now connected to the ground on the switch mode power supply. So let's try to check if this is really 5 volts. So I will be connecting the positive terminal on this terminal here. Okay. What's the voltage, guys? 5 volts, 5.27. That's fine, right? How come this one? The next one, I'll transfer this one. Still, we maintain the ground connection, okay? I'll place the positive terminal on this terminal here. What comes out is 12.16. In electronics, if we say 12 volts, it could be more than 12 volts, but because we don't place the 2 significant figures just to make the writing very good, you don't say 5.27, you just say 5 volts. You just say 12 volts, you don't just say 12.12 volts, you just say 12 volts. Okay, the next one. Okay, 12.16, 12.17, right? Next one. It says, because I did this already 10 years ago, okay, I just put it on my storeroom, right? So I bring it out, I'm using it now. Actually, 12.16. Okay, next one. It is 5 volts again. It is 5 volts. So this 5 and 5 is actually 5.27, and the one I say 12 volts is actually 12.17. It doesn't hurt, right? Because if we are specifying voltages in electronics, we don't say 5.27. Your power supply is 5.27 volts. We just say 5 volts. It could be 5 volts. It could be 5.1, 5.2, 5. It's something like that. Okay. So this is an example of a switch mode power supply, and the way how these voltages are produced. It is this. Okay. We got like this one here. We got 5 output voltages. So if we try to summarize this, there should be 5 high frequency transformers on the secondary side. 1, 2, 3, 4, 5. Right? The first one is 5 volts. Next one is 12 volts. Next one is 12 volts. Next one is 12 volts. And the last one is 5 volts. And the circuit diagram on this portion here, just to produce 5 volts, it's just a single diode now and in small capacitor. Okay? Anyway, the frequency is too high. Okay? If the frequency is too high, if you try to see that on the oscilloscope, the graph is almost a straight line. You could not even see the, what they call these oscillations. But if this is 60 hertz, and if you try to see it in the oscilloscope, the graph is something, it's a rugged one, by the way. That's why for high-end electronic gadgets now, the frequency on the secondary side for the power supply is actually very high, such that the rectified current will be as smooth as possible. So what they call this, the digital component will try to operate without any what they call this hassle, right? Because you cannot just inject 60 hertz there and you inject it into your digital circuit. It might not work. Okay, that's why design engineers now try to design high frequency switch mode power supply such that the frequency on the secondary side is very high. So when we try to rectify it, it is very smooth already. The pulsations is very minute. You cannot even see by the human eye. Not unless you put it in the oscilloscope and you try to enlarge the signal. That's why for high-end electronic gadget now, the frequency on the secondary side to produce these different voltages, it is actually in the range kilohertz and megahertz. And if we try to rectify those kilohertz and megahertz frequency, okay, the graph will be very smooth. It is almost perfect straight line. Okay? Okay, that's it, guys. That's how a switch mode power supply works. Okay? I will repeat it. This ground here is same as this one. So actually, I could transfer this ground here. So it's still, the reading still the same. This is black and black. So the potential of this one is same as this one. So when measuring these voltages, you could either use the left ground or right ground. It's the same. Okay, I will try to transfer again. This will be 12 volts, 12.17. This will be 12.17. Again, this will be 12.17. And the last one will be 5.20 volts. Okay. So this terminal here is actually very handy because if you needed 5 volts to power up a radio, okay, you just place your negative terminal here and you just place the positive terminal here, and you will be alive already by using this power supply. Okay. Okay, that's it, guys. That's the concept on how we produce a switch mode power supply and the different voltages on the secondary side. The requirement is that the transformers on the secondary side should be the high frequency transformers. The frequency of those transformers are actually in the range kilohertz and megahertz, such that when we try to rectify it, okay, the rectified current will be as smooth as possible, and that is actually what digital circuits needed. Okay? But the lifeline of these high frequency transformers is actually the switching transistor on the primary side. Without the switching transistor, we could not produce the frequency required on the primary side of the high frequency transformers. Okay, it's a must that there should be a switching transistor here. So if you try to Google what is a switching transistor, what will be the transistor that will produce a frequency maybe in the range kilohertz and megahertz? We could do that. But just for simplicity, this is the simplest way on how to bring out the concept and how to produce the different voltages for a switch mode power supply. This is for now. It's good afternoon here in Los Angeles. Okay, this is Professor David J. De Los Reyes. So for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJ De Los Reyes. Okay, my channel contains long video format topics on different mathematics like differential calculus, integral calculus, differential equations. I got 10 subjects uploaded already. It's a complete thing. And my short videos, okay, it comprises of electronic and some other things. The title of my short videos are actually on the so-called how-to thing. Okay, good afternoon from Los Angeles. This is Professor David J. De Los Reyes.